Computer Vision Web Development course is here. The power of computer vision now goes into the browser. It's very easy to create computer vision projects, but it's very difficult to bring them to the market as final products. I have made many courses and YouTube tutorials on computer vision with Python, which are excellent to get started, but providing it as a solution to a company is extremely difficult and not effective. So here is the solution. We have created Computer Vision Web Development course. Here you can create your own computer vision ideas and deploy it to the web as web apps. This will allow you to create solutions that can be shared with anyone with just a web URL. Whether you are creating a web app to do personal protective equipment detection or you are planning to do sign language alphabets detection, we have got you covered. Using the computer vision web development, you can create and deploy your computer vision algorithms at ease while maintaining and scaling them. We can run simple computer vision algorithms to complement complicated custom object detectors right in the browser, but it is very frustrating and difficult to get started. Here is where we got you covered. We have successfully designed this course to take you from the very basics of web development right up to the point where you can create your own computer vision web app at ease. In this course, we will be using world's largest computer vision library, OpenCV, along with the most popular deep learning framework, TensorFlow. So you don't need to worry about latest tools and technologies. Here is what we have included in this course. We will start by writing the bare minimum code to get started with OpenCV and web development. And we will do a very simple project where we will have a few buttons to convert an image to grayscale or find its edges or blur the image. So this will be a Photoshop application and we are going to create this simple project at the start. We will go ahead and create a color detection application where we will learn how to create track bars in the web app. In this project, we'll detect the orange color of the car by varying the HSP values using the track bars we have created in the web app. You can also use any other image and deduct any specific color you want. Before we go towards the advanced topics, we will create a shapes detection application to detect different shapes in an image, which include square, rectangle, circle, triangle. Here we will learn the basics functions of OpenCV, which includes contours, corner points. We will find edges using the Kenny edge detector and so on. We will also learn how to apply masking and many other functions are included as well. Next, we are going to look at the advanced topics that are really applicable in the real world application that also include face detection. We will learn how we can detect faces in an image, video, or in a live webcam feed. Now we will learn the basics of deep learning with TensorFlow on the web. We are going to learn how to use TensorFlow on the web. Here we will learn about object detection and we will also learn how to create custom models to create real world projects. This will include a lot of different projects that will give good knowledge of how to utilize the data to actually create amazing projects. We will start with using pre-trained models for testing. We will learn how we can do real-time object detection in the browser using TensorFlow.js and Coco SST model. We are also going to look at object detection in images and videos in the browser using Coco SST model. We will also do object detection on the live webcam feed using Coco SST model as well. Now the most exciting part starts. We will be using the latest state-of-the-art object detection model YOLO V8 to do object detection on images, videos, and on the live webcam feed. We will first use pre-trained YOLO V8 model. We will convert the YOLO V8 model weights to TensorFlow.js format, and then we will do object detection in the browser using YOLO V8 pre-trained model weights. Going ahead, we will now look how we can train or fine-tune the YOLO V8 model or any custom data set. we will train the YOLO V8 model on personal protective equipment dataset, which is available on RoboFlow. Then we will convert the fine-tuned model weights, or after training the YOLO V8 model on personal protective equipment dataset, we will convert the fine-tuned model weights into TensorFlow.js format, and then we will do personal protective equipment detection in the browser, in images, videos, and in the live webcam feed using YOLO V8 and TensorFlow.js. Furthermore, we will train the YOLO V8 model on American Sign Language Letters dataset. Then we will convert the fine-tuned YOLO V8 model weights trained on American Sign Language Letter dataset into TensorFlow.js format, and then we will be doing American Sign Language Letters detection in the browser, in images, videos, and in the live webcam feed using YOLO V8 and TensorFlow.js. Last but not the least, we will be doing license plate detection and recognition using YOLO V8 and TensorFlow.js. We will first train the YOLO V8 model on license plate dataset, and then we will convert the fine-tuned YOLO model weights into TensorFlow.js format. In the next step, we will first only do license plate detection in the browser, in images and videos, and then we will use TensorFlow.js to extract the text from the license plate. So we will be doing license plate detection and recognition in the browser, in images and videos using YOLO V8 and TensorFlow.js.